Hi everyone, I decided to make a tutorial for this procedural braid setup, as I think it's a quite good example of how these arrows work and how to work with matrices, matrix contrast, construct, matrix compose and stuff like that. So this setup uses one curve that is the control curve, and everything is built around that. So I got the idea for this setup from the William Wokan's quick video, and let's look that first so we can get idea how this works.
Yum, yum!
William Vaughn here with a quick Modo modeling tip for creating braids. Start by creating a straight Modo curve with 9 evenly spaced verts in the top viewport. Adjust the verts to create a smooth S-curve in the top viewport. In the front viewport, create an infinity symbol, moving verts 2 and 6 down and 4 and 8 up. Using the clone tool, create multiple copies of the curve the length you'd like the braid to be. Use the Merge Vertices option to connect all the duplicates. Merge all of the curves together into a single curve using the polygon merge command. Make 2 copies of the curve, offsetting them to generate the braided pattern. Use the Render Curves option to give the curves a surface. Adjust the curve radius to thicken the strands to the desired amount. If you want to create geometry instead of using the Render Curves option, simply curve extrude a flat polygon along the length of each curve. Oh, look at the time.
Okay, so now that we know how to make it in 60 seconds, traditionally, maybe we can tackle this in 60 minutes. So the basics of here is kind of this one, because this creates an array from the curve, and this array operator is the one that moves these points in the way we see in the Williams video. So, and this is just duplicated few times. So this is the like one basic curve, and then we have one copy of it, and then the other, and offset a bit. So let's start with the new scanner. Let's take this one, and first thing we need the curve. So let's make actually a item for the curve first. Okay, and top we have. I start with just a straight curve, so it's easier to see where the things move when we start to move them. So it's there. I don't know why it's not in the center, but does it matter? Maybe not. Let's move it in the center. Okay, now we have it in the center. So we have our curve here. So next thing we need is to make an array from that curve. So we need a curves to array operator. Let's close that and look in that curve, and here we have the array. So we have positions. For this one we use transforms, but let's be position for first. The difference is that I'll just copy it for this example. So if we have this curve here, and this is like positions, they don't rotate. If we take transform, we have it takes account the curve's normal direction and rotates those. They aren't locators, they are like elements in array, and they are transform matrices. I'll get back to that later, but let's keep that straight curve. So I made it steps 9, so we have kind of same starting point as the William had, and then we have to move. I don't remember, I think it was 1 and 3 somewhere here, and that a bit longer and so long. So what we do for the moving, we add array operator. And we got this here and here. Maybe for at this point a bit too late, a bit of disclaimer that I use quite a lot my own hotkeys when working on schematic for like separating channels and adding channels like this. So I have a kit for that, but I'm not going to explain everything. I may explain something. And also I use a kit called Harry by Stephen Hill few times. This could be done without it, but it's a bit more complex. It's just it's not difficult, but you need to create many nodes and stuff like that. And it has the arrow print node, which is really useful, the Harry kit, in the Harry kit. So where we are, we have this array that we have to manipulate some of these vertices. So with arrow operator we can do that, but let me show something about the arrow operator, how it works. So I think it's a useful information. So I made this example scheme here, and here we have our array operator, and here we have arrow print. This is from the Steve Hill's Harry kit, and it just prints what is in the array. So we have here curves the array, and okay, it's some kind of local tangent. We can take it a position, so we can see the position array here, and we can make it, for example, transform, and we can see the transform matrices here. It's a bit hard to read those, but there they are. So what does this one do? It goes through every element in the arrow and does something to them. So if we have element out, it reads the element, and element in, it puts the same element back. So it basically does nothing. So we can, if we do this, then it takes the index number of the current element, and you get the index numbers like this. And it doesn't matter, I have here an other arrow which is like doccat. Let's see, now it index numbers because it changed it. We can see dog, cat, mouse, horse, goat, turtle. It's the same here. And this is also from the Steve Hills kit. You can we will use this because it's a easy way to create array from the scratch. It's possible with a native model, but you need to use some stupid tricks. Not hard, but stupid. So let's put this here. Now I'll show the one thing. It doesn't matter. It's like this changes. It doesn't matter what you input here. You can replace it with whatever it is. It's like this can be strings input, and you can output numbers. So let's get this arrow. So we can do things like let's multiply this by do. Now we multiply the index number by 2 and we get this. And let's remove it, and we can do it also like this, that we get this arrow from here and we read the index from here, output. Okay, so now it's converts. This is the input arrow, and it replaces the values with this arrow values, because it takes the index and takes the value that is in that index to this output arrow. So maybe that makes sense, or maybe not. Let's continue. So where we are, we have this array operator, and we want to move those things. And I think I need to explain next thing, what is this transform matrix. But let's add this element out. No, it got element out, element in. So now we have what was the first example here. So it basically does nothing. But then we can have also let's make a curve from this straight away. So I make a new mess, and let's name it this spread curve. So this is the curve that will be twist like the braid. How do you say that? I don't know. And I think it's a make polygon. No, it's create. Sorry, this opens always create polygons. So with this one we can take the positions from this curve, and I have this isolate mode hotkey, so I can see only this one mesh here. Face polygon to a curve and none. So we should have this curve here now. Yes. So what we need here is matrix compose. Let's look how I have done it in this working version. So this is the array operator, and this is like the transform matrix of each element. It compose it with this author transform matrices, which tells the element where to go. So let's create the matrix compose first. So let's add matrix compose. Wow, I'm not able to write anything. Compose. So this is a first thing about this is it matters in which order you put input stuff in here. I'll get back to it, but it's there's no indication of that, but it matters. So we can try the I add a locator here. It's just nothing special, just a locator. So, and I'll add a word position, and I'll add it here. And if we select this, and if I move the locator here, it move the position of each of these array elements, because this matrix compose combine the transform matrix in this array and the transform matrix in this locator. And we can add a word rotation, and let's see what it does. Also something similar. Okay, let's rotate it. Yeah, okay, but here we see that it does matter. So now our result is this because we plug it this way, but if we rotate first, and okay, now the result is different. So I have also Skenep for this one, which might help or may not help to understand what is happening. So let's see. I have this locator here, and there's not the one thing I'll need to maybe explain somehow is that the transforms that this array curves the array transform, it uses 4x4 transform matrices, and there's there is no transform matrix output in the locators or any items. I don't know if it's used inside. I think it's used internally, but you can only get word position, word rotation, and word scale matrices, and from those you can make this transform matrix with the matrix compose. And in here also the order matters, so you have to go from top to down. First scale, when you plug it in, you have to go scale first, then rotation, then position. And now we have this transform matrix here. We do it like backwards, or just nothing. So this is only for example purposes, because there's no reason to do it like I do it now. But I'll take the matrix, transform matrix here, and from this one, with this one we extract the translation, so the position of the transform matrix, and it's will come out as a vector, and from that vector we create again a word position. So we could do it like this is exactly same thing, but as we want to compose stuff, we do it like this, bit complicated way. So as this is this locator, as I plug it in, it will not parent, it will be like constraint to that locator. So if I move, it will move with it. And if I add rotation, it will rotate with it. So this is quite boring for now, because you can do this by parenting or constraints or everything like that. But it gets a bit more exciting when we compose two matrices. So we have this auto locator here. So if we take it like this, so now it follows that one, but we can add this here. Let's go other way around. So now it still follows this one, but if we add this world position here, then it goes, it has this rotation, and it takes the position from this one. But if we plug it other way around, so we move first and then rotate, we get different results. So it's kind of, I don't know how to explain it, but you can see what the difference is. It's and this is the result we want. So if we rotate first and then move, then we get this result we don't wanna. And it's kind of logical if you think it like with this one. So if we move something first and then rotate, it's like it gets different result than if we rotate first and then move. So we are here. So this that's why the order matters, and we can, it's very helpful for us. We can utilize that. So back to the tutorial. So it was this kind of, so where we are. So we have this array which we need to manipulate. So we have to move certain points to one direction and others to other, and so on. So first thing we need is the index output, so we know what element we are moving and which direction. So we could, let's use this for the example purposes. So we have position here. So if I just plug index to position, let's see. No, we can't. We add this. Okay. So we get quite of interesting results. So we can multiply it by 0.2. Okay, so now that we can see the curve, we can easier manipulate what's happening. So now that we multiply, that we can see the curve change. So what could be the next step is that we get rid of this locator, and let's make this like matrix from this scratch. So I'll check this one, how we have done it here. I'm not sure. Matrix construct, yes. So let's go back to here. So we use matrix construct. Construct struct, and to here we can input the same to the X and plug it in here, and we have the same result. But now as we want to have like certain vertices moved other direction and some doesn't move at all and so on, we make an array for the each move position or movement, and for this we can use the create array, which is from the Array kit, and let's add enough of these inputs, so we can math. Let's add basic math, so we can have input 1 is 0, and if I remember correctly, there was the second and third moves somewhere, so there's a 1 between. Let's put some value here 2, and now let's plug this in, give it a color like what is the x-axis is red, so this will be our x offset. We can name it also array x offset or x offset array, and from this array we get elements by index. What I'm clicking here, array element by index. Okay, so we take this arrow here and we take this index number here, and then we take this here. Okay, so we get quite interesting results, and for this purpose also the arrow print is invaluable because you can see what's happening. So we have only 3 here. So what we have to do is first we have to connect those, but before I do that I'll make a locator where I store those values as user channels. So our first user channel is 0, which is just 0. So everywhere that there will be 0 we will add 0, but I'll do it in that one is not. I'll do it with each input. Now it's zeroed out. So, and then we need offset x and float, and this one goes to here and here, and this, no it doesn't, because now we start to maybe see what's happening. And this one I move. This Etherea's quick locators kit. Ethereum channel hole. Some nice color. No, no, even click, we can. There's a bug here. User channels of steer. Okay, now it offsets, but there's still something wrong going on. I'll add because as in the tutorial we have to move this one little and then this one a bit more and this one same amount that this one. So I'll add a math node here and input it there and change it multiply, and that can be 1.5, and I think it might be a good idea to add a control for that. Let's make it a curvature, maybe. I don't know if it's a good name, but let's go with that and plug it that in there, and now we can, now it start to look something like we are maybe going after. So we can now change this and get the first part done. So let's see. So this input, I think it's like, this is a bit messy, but this is a 0. So for this one we need this offset. No, it went too wrong. I think it's a yes, that one, but we make it negative with the basic math node. This is something I have made myself. Maybe I try to share it someday. Just need to find a good place for that. And then I get this here, and this is also, this is a same but negative. So now we have that basic shape in one dimension, and what happens if we increase the amount? It doesn't work. So we have to use a math modulo, I think, which gives you the remaining of the, if you divide something with something, it gives you the remaining reminder of it or something like that. You can Google it. There's definitely better explanation somewhere. And we plug in the index number there, and so what does this does? It will always give like a number that is between 0 and 8. If it's like 16, then it's 8. I will add steps also here. One nice little trick is that you can take this as steps and drop it here, bind as user channel. And but it gives you a like stupid name. Okay, now we have steps there. Okay, now it's working. Don't know if you followed what happened, but maybe if you redo it yourself, you understand. Yeah. What is nice is that if we take this other curve here, so it follows that curve here. But I don't know. Now we have to... Yes, now we have that problem because it is following the curve, but it's not doing what we want it to do. And solution for this is to change the order. We have connect the stuff here, so I think we have to take this matrix first and then take this. Yes, now it kind of we can add the steps and maybe make okay. In this setup I will not have any controls for the twist or rotation in the direction of curve normal. I'm planning to make a part 2 which could have that one and also the scale, but that's later. So the trick was this order, which is very important, and I wish we could have update to where we can change that order easily. So next thing we have to do is to add the X, no, not the X, the Y movement as in the Williams video. But this is it's kind of interesting that it moves in the other direction now, but that is because we see the X direction is pointing in that direction here, and it's not the word X. So this matrix compose, I hope I'm right, but it works like in its own local coordinates, so it doesn't use the world coordinate. So slowly going forward, and I think we add the the other movement here, like up and down, and this is also quite slow when there's a lot of these. Actually, I'll check if I can. I think there's an option to hide those. So I found it. We have here draw array indices, and if we look geometry without indices, it's like 16, and with indices like 12. Really bad performance, but we don't need those. We don't need those for now. So what we do now is I'll duplicate this one. We get the, we will make a y. We will make a offset array for y direction also. I'll remove this and I'll put it like this little ordering, and move this up and put this to. So duplicate this. Okay, we have to add all the channels. Let's make it green like a Y, and add those inputs there. Okay, and I think it's better to have everything 0 at first. And let's give it a user channel offset Y, or did we have, yeah, okay, that's same convention, offset Y, and let's adjust somewhere that, and give it some, of course it doesn't do anything yet because we have to have it also here. We added this matrix construct with added to translation matrix. So I'll separate this. I can have it nicely here and use duplicate that node, and this is our array and this is our index, and we can put it here, input, and nothing seems to happen because I don't know if we have anything in that arrow yet. Okay, we have only zeros. I'll add a backdrop for this one, but I don't want those there because this is kind of set up for one curve. I tried to change the name, but I misclicked. Braid curve, no. And let's see what is the value for that. Now we can see it does, it moves, gives a little dance for us. Nice. So let's see, I think you can go to the tutorial, William's tutorial, or I'll check from the author scan which points we have to move. So to this scan, and let's see arrow. So it's input 3 and input 7. Input 3 and input 7. So I had the right one, and then this one, and this one is then negative, I think. Okay. Does it look right? I'm not sure. What we I'll change the order of this. I'll move this here so it's a bit more nice. Somehow it looks wrong for me, but it's because we don't have input 0. That lacks. So now it might look a bit more like it should look. This is a messy one, I have to admit. It's hard to see where those things are going on. So as I'm looking here, it's also the input 1, and this goes to 0, 0, this is negative. Input 1 and 5 goes to offset Y, so this goes here. And 1 and 5, and this goes also here. it's looking a bit strange now. Let's see. Sorry, you can fast forward this part, I think. So zero, 2, 4, 6, 8. Those are 0. 0, 2, 4, 6, 8. Those are correct, but then we have this negative input 3 and input 7 are negative. So now it starts to look correct. And this is strange. This that it's like this kind of, it turns the curve, but let's tackle that in a next tutorial. So we have it now like this, and it gives a quite nice curve, I think. So what we can do now is let's add a curve sweep for this, and for that I use a great kit by Mateus. I'm not trying to say his Polish name. Schematic nerd, and we can store and save node assets. And I add here, I have made curve sweep basic. Okay. I think I'll add the other one I've made at curve sweep mestack. So if you want this kit, you can go to Slack and find the Modern Nerdist channel or something like that, and there's a alpha version of this. So let's just make a path mesh there, and there we have the first braid made. This has been a bit mumbling, but I try to mumble less in the rest of the tutorial. So let's take the size from here. Does it have an effect? Yes, it does. Drop it there, and then we have user channel for it, and we can also rename it, I think. Radius, maybe comme ça. Okay, now we have this one braid ready, I think. We can let's make a big longer curve. There's like, it doesn't, if the curve gets longer, then it not get longer, but I think I will address that in the next part, if I'll do one. I think I'll do, because there's I want to have scale to it, and I want to have control over the twist. But now, as we have this first braid ready, we have to do the other third and second, and it goes a bit similar way that in the Williams tutorial. I'll remove that there and give it some color. So we duplicate this whole setup. I think we could also make it an assembly alias and do it that way, but I want to duplicate it like in the scanner. And for that we use the kit I mentioned it already, the schematic nerd, which is in alpha, and you can get it free from the Slack. Because let's try it like this. If I duplicate it like this, it just makes a terrible mesh with the default duplicate command. But if I take this, I think these are the nodes I want to take, and I don't wanna take these. I'll wanna take only these, and I'll use the schematic nerd. I'll go here, store node set, and braids, braid curve. I'll name it like that. Okay. So the backdrop doesn't work with it, but, or I don't know if it works. I forgot to select it, but it's like a minor hindrance, because I think it should work like add node set and braid curve. I hope it was this. Okay. And now we have the notice here, which is quite nice, and we can hopefully do like this. Let's test array operator. So this is where we are having our bread. Let's braids curves. Let's make it like, because there's more than one, and let's make a stack here and create polygons and duplicate this one and move it here and positions. Okay, yes, now we have it here. So we can, I'll keep it a different curve for now, because if I use same curve, then we, how we see it, I can use same. I'll add a backdrop for this one, and we have the steps here, which is not I'll separate it and get it here, so we have same number of steps. So now we have the problem that we can't see the other one, so let's move it here for a while, and we need to offset this. So let's use this start and end property here. So I got a bit lost, and so the thing we have to do next is that now I make it here, that curve. If we use that curve, it will be there, but now they are both in the same place, so we have to offset this other braid so that it's not in the same place as the other one. And for that, I think we use this curves to array start and end parameters, And what we have to do is there are 3 breadths, and so one is cut from the end, the other is cut from the start, or moved the curve, so we offset it, and third is shortened from the both ends. So we will first I want to change this this from auto to okay. In next part I will make this so it will change automatically to the length, but not now. We need curve probe for that. So start. So we take a part of the start, we remove a part from the start. So let's add user channel and name it offset length. Could be possible. It can be percentage, and let's use minimum value as 0, and let's hit OK. And it's here. So let's try if I can get it to the same. No, I can't. Let's remove it. Offset length. Okay, now we have it here in same locator. So let's first check what is the like. I think it could be like 2% for a start. And so now we see that the other curve is moved a bit forward, but we have to compensate. So this is a end, but it can't be 2%, it has to be 100 minus that. So it's 1 minus subtract. So now it looks something like it could work. Oh, now we have to add the third curve here, but we can use the semantic layer. So it's here, and give it a box, move it here, and let's take this from here and this from red. It's nice to have colors so you know what you're doing. So this one goes to here, and we black need create polygons here. The order doesn't matter, and positions there. And curves, we block the same curve here. Okay, now it's getting to the one. We add the steps. Now it's apparently over some other curve, and we add the start and end, and we for the start we use this value, but I'll take it this, but divide it by 2. sure if I did it right or wrong. No, that has to be the end value, and the start value is this. Divide by 2. So now we might have or might not have what we want. So let's move this here. Let's try the straight curve. A little less of this. This one. Okay, I have some problems here. I think I have messed up my math. So this end is that end. Okay, that end is totally not what it should be. So let's remove this and we get offset length and take 100. Okay, wrong way. 100 minus. Now the maths should work, I assume. No, it doesn't look right yet, or does it? No, there's something something strange going on. So is offset, let's say 10%, so it's easy to okay, so it's 0.1 there, it's right. 0.9 there is right, and here we have 100.5, so we have to change that to minus, and it should be correct, but it's still something that doesn't look quite right. Okay, I found the problem because I'm thinking about percent, how to say, and this would be 1. So does it look offset? So now we can, now it's getting interlocking, and we can adjust that, and we can adjust that. So now we can swap the curve. And it looks like this. And so in the next part, which I hope I will be able to do at some point, I want to make adjust it so that this works automatically. So now we have to adjust the offset every time, and I want to have this automatic steps. We can Clark it so it's look better. So I want to have scale adjust and twist adjust and Not sure, maybe delete these parts here. You can do it manually also afterwards if you don't want to need to be fully procedural. So I hope you get some insights of this how the arrays and matrices work. And let's see, I hope I can do the next part soon. I have some friends from Finland visiting here, so it might be take a week or two. Actually, I want to show one neat little trick, which is possible with Steve's. Not sure. I think it's a poly kit. It's a channel bundle. How do I write it? Channel. I'll take this one and I'll take this one, and I'll remove those. Oh, actually, take every, because these are not so nice looking, these links. So we can use remove those and add results here. That can be removed. Result there, and that can be removed. Sorry. So channel bundle, it takes we can take channels and bundle them. Let's remove that and remove that, and so we take, just remove this all, and so we have this channel, and this can take like everything. It can take an array, whatever, and we have input here, and separate these outputs, and we can get it here and here, bang bang. So we move it here. It's like, and then we can duplicate that, one more, check what I'm doing, hitting wrong, then remove those, separate those, move this here, and move this here, and like this, and then we can have some nice color to them. So I think it makes much nicer schematics like that. We could have some nice names for those, but let it be for this time. So that's all. You can like and subscribe the video, of course, and I have Gumroad and Coffee site if you wanna support or get some of my stuff, and I'm planning to do more like assemblies and share my UI interface, like this kind of this. I'd like to figure out a good way to share those, maybe Patreon, I don't know. But have a nice weekend, whatever it is, and see you later.